Hey everyone, this week we're going to be having a couple of things. So the quiz is going to be, if you're watching this on Monday, today, the quiz is going to be tomorrow, Tuesday, September 29th. Like I mentioned, the quiz is going to be open all day, right? And I'll show you where to access it and what I want you guys to do. The quiz is going to be open all day, but once you start, you will have 30 minutes. So again, like I mentioned last week, uh, have your calculator ready, have your notes ready, have your pencil, paper, and your phone, especially, right? Have your phone ready, and have the app, the scan app, Tiny Scanner app, downloaded. That's how you're gonna get it to me, right? So once you click on course modules, module 3. Again, if it's Monday, you won't see it because it's going to be up tomorrow. If you scroll down, you'll only see these 3 things, right? Including the assignment, the first assignment, which I'll talk about in a bit. But tomorrow, you'll see something, tomorrow meaning Tuesday, you'll see something called QR Quiz 1. Let me show you how that looks like, right? So you're going to have the readings for the critical issues, and then under that, you're going to have the quiz, and then you're going to have the assignments. So once you click on it, right, but before, make sure you read this, right? This quiz will only be available today, meaning on Tuesday, right? And once you start, you'll have 30 minutes to finish it, right? Make sure you have paper, pencil, calculator, just like I said, phone ready. If you haven't already watched module 2, watch that part before on how to submit the quiz, right? So I'm not going to go over the tiny scanner again, but that was on module 2. Make sure you watch that. If you have any doubts, contact me before you start. Don't contact me after, right? If you're worried about how am I submitting or anything, watch this video. This part of the video is going to show you how to submit. You have my email address, but again, just contact me. So once you start, a new window will open up. You have a time limit of 30 minutes. It says I have 20 minutes, but because I was just messing around with it, but you'll have 30 minutes once you start, right? Hit continue. There's going to be a timer up here, right? You'll see warnings will come up when you have half time, 5 minutes, 1 minute, 30 seconds, right, remaining. So here's the quiz, right? It's going to look exactly the same. So be sure to write your answers on paper, upload the photos of your work using the app, the Tiny Scanner app. I showed this on module 2. Make sure you show all work. No, if you don't show work, you will not get any credit, right? So make sure you show work, right? And I do get partial credit, except for you'll see what I mean, right? I do get partial credit. So here's quiz 1. You click it, right, and it'll open up for you. I'm not gonna click because you guys are getting a sneak peek. But once you finish your work and you take a picture of all your work, you save it as a PDF, right? Make sure your PDF is in your computer, right? Then you click Browse My Computer, and you look in your folders, wherever your folder is, right? I have a couple of stuff here, but you click it. You click you click the PDF. So let's say this was the PDF, and then you hit open, and it'll come up, and then I think it'll ask you to upload or something. So let me just try, right? So this was this week's worksheet, right? So let's say I upload it, right? Yep. And then you hit save and submit, and then that will submit it. Okay, so it's saved. So that's how it would work, right? But I'm not really going to do that. I'm going to remove it and then close the window. So that's how you would submit the quiz, right? So make sure you open it, right? Make sure you're ready before. Click that file to open up the quiz. Read the questions, right? You don't have to write out each question, but make sure I know what you're referring to. Question 1, question 2, so on and so forth, right? So make sure I know what you're answering. Box or circle your answer in your paper. Write your name on the paper, right? That's a big thing. Write your name, and then take pictures, save it to a PDF, and then submit it. Now, before we get to today's lesson, let's talk about this week's assignment, right? So let's click on that. I think I already had it open. Yeah. All right. So this week's assignment, assignment 1 is due on October 4th by 11:59 p.m. So don't start it last minute. It's going to be due Sunday, but try to get it out the way ASAP. The table below shows the population of the largest cities in the United States in 2002. It also provides each city's areas in square miles. The population density, which you guys know how to solve, is the average number of people in a living area, right? So how compact they are. So it's expressed as thousands of people per square mile. In this case, millions of people in square mile, right? Calculate the population density of each city on the table, round it to the whole number, right? So there should be no decimals, round to the whole numbers, and then you're going to refer to the table to answer the questions. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 cities. You're going to calculate the population density for all of them. You should know that, right? And you write directly on this, right? So whatever the numbers are, you write directly on it, and then you're going to save it, right? So you're going to go File, Save As. What's all this stuff? Whatever. So you're going to save it as assignment 1 with your name, right? Make sure you have your name on it, right? And then, so you're going to complete this table, answer these questions about 1 or 2 sentences each. What are the 2 most populous cities? What's the difference between population size and population density? Which 2 cities are most densely populated? Is your town or city densely or sparsely? Sparsely meaning it's not a high population, or dense means it has a high population density, right? So is it a lot or is it small compared to the other ones, right? What is the effect of population density on environment and quality of life in your neighborhood? What do you think, right? 1 or 2 sentences each. Next, and by the way, you don't have to for this assignment. You don't have to show me how you calculate it, right? I just want to see if you got the right answer, right? I'm more focused on the number itself and the questions, right? How you answer the questions. Next one, very similar, but this time you're looking at 20 different countries around the world, right? So sometimes I give you the population and the land area, and I ask you for the density. Sometimes I give you the land area and the population density, I ask you for the population. Sometimes I give you population and population density, I ask you for land area. You have the equations for all 3 of these, right? So if you're given 2, you should know how to solve the other one, right? Check the video on module 1, yeah. Module 2, excuse me. Check the video on module 2 when I talk about density. If you are getting stuck in this, right? I want you to fill this table out again, round to the whole number, right? Find the missing variable, round to the whole number. After you finish, answer the questions. 2 questions only, paragraph each, right? So 5 to 6 sentences, not 2 or 3 sentences, 5 to 6 sentences, complete sentences. Make sure you check your grammar on both of these. So the first question, what do you think plays a bigger role, population or population density, when it comes to environmental factors such as pollution and disease control? Do you think that there are other countries, do you think there are any countries in this list, right, that have high risk of spread of COVID-19, but are not talked about in the media? Why do you think they're not talked about, right? Or why do you think they have a high risk, right, according to this table or according to what you think? Next, the United States is by far not the most densely populated nation in the world, right? However, it has the most deaths, unfortunately, has the most deaths and cases of COVID-19. What is your take on how we as a nation look at public spaces and interact with others in public domains, which is critical in the spread of pandemic, right? So everybody knows that we got to keep 6 feet distant. We got to keep wearing a mask, right? And we have public spaces in America, right? How do you think we're interacting, right? How do we think that we as a nation have dealt with how people should be in public spaces, right? And how has that influenced the deaths and cases of COVID-19 in our country, right? I want you to talk about that a little bit in the assignment, right? And again, same thing. You click on this assignment. It's going to tell you 50 points. It's due this day, right? You're going to open up, you click here, it opens up that same document that you click. Browse your computer, right? Remember, you're going to be working on this, right? You're going to write everything right here. You're going to write all your numbers, and right underneath, you can write your answer, right? So you can type answer and then start typing whatever your answer is, right? Same thing with this right here, right? You go say, I'm going to move this to the bottom. You could just start typing right here. Answer to the first one, start typing. Answer to the second one, start typing, right? Don't write ASTAS, right? Actually write sentences, right? So you could type here, file, save as. And remember, have it as a document or a PDF, right? Because Blackboard has trouble with other types of files. It's going to get saved to your computer. You're going to click Browse My Computer, find that file, upload it here, and then submit, right? If you could upload photos on social media, you could upload files on Blackboard, right? It's exactly the same way. All right, so let's get started on today's lesson. Where course modules, module 3. Maybe I should put it in the description as well. But anyways, you're gonna have it here, right? This video, I'm gonna post it, the link right here, right? You'll have it. That's how you're gonna get to see it. The quiz will be tomorrow, just Tuesday. Responses like every week. Response by Friday midnight, before midnight. Assignment 1 by Sunday before midnight. Right. So let's get started. This week we're gonna be talking about understanding ratios and proportions. Right. So what is a ratio? Right. A ratio is a comparison between two different things. Right. A ratio tells you how much of one thing there is compared to the other thing, right? And usually it's two, but it could be more, right? We'll talk a little bit later about comparing three things, right, in a ratio, but it's usually two, right? A ratio is also a relationship between two numbers indicating how many times the first number contains the second, right? So ratios are used a lot in recipes, right? Ratios are used a lot in buying groceries, right? If you think about purchasing different items, you're looking at this one cost this much, right? This one costs $10 and it's 4 ounces. Another one costs, let's say, $15, but it's double the ounces, right? Which is the better value, right? You could think of it that way, right? So ratios come in handy a lot in day-to-day activities. So here's an example of a ratio, right? So let's say I gave you a statement, right? 20 car accidents occurred on this highway. Let's say there's a highway, and I tell you 20 car accidents occurred in that highway. Now, there's two ways you could think about this. Did 20 cars out of 40 cars, did 20 accidents happen out of 40 cars, right? Or was it 20 accidents in the first year, right? Just telling you 20 car accidents occurred doesn't really give us much information, right? It could have been, let's say it was 20 accidents out of 40 cars. That's crazy, right? 20 accidents, 40 cars, that's half of the cars that were on that highway got into an accident, right? So that's one ratio, right? 20 accidents out of 40. Another ratio is 20 accidents in the first year. In that first year, in that highway, thousands of cars drive through that highway, right? Even though 20 accidents is bad, it's still very small. If it's thousands of cars every year and only 20 accidents happen, that's still a lot better than half of the cars, right? Half 40 cars, 20 accidents, still better than that, right? So ratios tell you comparison between two things, and here the two things would be number of cars versus number of accidents. Now, when we talk about ratios, there's two ways of thinking about it, right? There's the part-to-part ratios, and there's the part-to-whole ratio, right? Part-to-part, and I'll go more about this when I give examples, right? But I'm just going to give you the concrete definitions for now. The part-to-part ratios means it gives you the relationship between two groups, right? Two distinctive groups. For example, the ratio of men to women in a classroom, let's say, is 3 to 5, right? Here, one part of the group is man and the other part is woman, right? So that's 3 to 2. Or the solution, which is a mixture, right, contains 3 parts water for every 2 parts alcohol, right? So here 3 to 2, right? That's the ratio, 3 to 2, 3 waters per 2 alcohols, right? Here in this case, these are parts of a whole, right? So the men and the women are part of a bigger group of, let's say, people. And this one, water and alcohol, is part of a bigger group, which is the solution, right? Or let's say a drink, right? Let's say you're making some kind of a drink, right? And part of it has water, part of it has juice, part of it has alcohol, right? So those are parts, right? Just like men and women, those are parts of a classroom or parts of a whole, right? Now, part to whole ratio provides the relationship between a particular group and the whole population, right? The whole population includes obviously the particular group. For example, 3 to 5, right? 3 over 5 of the students in the class are girls. So, meaning there are 3 girls out of 5 students, right? Where the students is the whole population, right? It's not 5 men or 5 boys, it's 5 students and 3 girls. Or the mixture is 40% ryegrass. 40% is equivalent to saying 40 out of 100 parts, right? So in a percentage, so out of that whole mixture, 4 40 out of 100 parts, 40% is ryegrass, and the 60% is whatever else, everything else. Okay, now let's do some examples, right? First question: there are 20 people in the classroom. There are 3 girls for every 5 people in the classroom, right? So this is very similar to the one, right? There's 20 people all together. There are 3 girls for every 5 in the classroom. How many girls are there? How many boys are there, right? So let's get started. By the way, if you didn't get a chance to see it, here's the solution for the worksheet for mod 2, right? So I'm going to scroll down slowly, so pause the video and then compare this to your answers. All right, so let's get to today's part. Right, so there are 20 people in the classroom, so that's our total, right? Let me get my pen out. Can I draw this? Nope. Okay, I don't want to get to that example first. Okay, so there are 20 people in the classroom. There are 3 girls for every 5 people in the classroom. How many girls are there? How many boys are there? So there's 2 questions, right? So first of all, you got to think, is this part to part or part to whole, right? They give us a ratio, 3 girls for every 5 people, right? So girls is a part, people is not a part, people is the whole, right? In that whole classroom, there's 5 people, so there's a part to whole type of question. So let's write this down. 20 black students, right? Or 20 people, right? There's 3 girls for every, so I'm going to do this, right? For every 5 student, right? And this is a part to whole type question, right? So there's 20 students in total. There's 3 girls for every 5 students, right? Now the way you think about this is you could put it this way: 3 over 5, right? So this is represents your girls, and this is your whole population, right? And we want to know how many girls there are in total, right? So this somehow has to turn into 20 students in total, right? So this is your students. This has to somehow turn to your 20 students in total, right? So when there's 20 students, how many girls are there, right? When there's 5 students, there's 3 girls. So when there's 20 students, how many girls are there, right? The way you do that is you think about this way. You think about what we call a multiplicative factor, right? So I'm going to erase this. I'm going to erase this right here. 5 goes into 20 how many times, right? How do we get from 5 to 20? And it's a multiplicative factor, so you got to think, right? 5 times what gives you 20? 5 times 4 gives you 20, right? One way, if you're having a hard time doing that in your head, which is perfectly fine, right? Use your calculators. You take the bigger number, right? It doesn't necessarily always have to be a bigger number. You take your ending number, right? Your 20 divided by your beginning number, 5, and you get 4, right? So the multiplicative factor, right? Multiplicative factor in this case is 4, because we're multiplying by 4. So if we multiply the bottom by 4, we're going to multiply the top by 4 as well. 3 times 4 gives us 12 girls. So we have, in the whole classroom, we have 12 girls, right? So if there's 12 girls, Altogether, how many boys? Number of boys. How do we figure that out? Well, we know that there's 20 students in total, right? So 20 students minus 12 girls should give us 8 boys. That's how we get the final answer. Now, when you're doing this, right, I'm going to erase this for a second. When you're doing this, just to check if this is 12 girls, right? Remember when we talked about converting fractions to decimals and percentages, right? This equals 60.60, right? And this also, 12 over 20, also equals 0.60, or as you guys know, multiplied by 160%. It's the same exact thing. So regardless of the ratio, the percentage or the decimal is going to remain exactly the same, right? So that's one way of checking your work. So the two answers: how many boys are there? There's 8 boys. How many girls are there? There's 8 girls in total. That answers the first question. Now, second question: there are 20 girls in the class. There are 20 people in the classroom, right? There are 2 girls for each 3 boys in the classroom. How many girls are there? How many boys are there? Right? In this case, is this a part to part or part to whole? What do you think? This one was part to whole, the first one, because you're talking about girls, which is a part, and people, which is the whole class, right? Which is the whole group, right? It's not one particular distinctive group, right? It's just everybody. This one, we're talking about 2 separate groups. We're talking about girls and boys, right? So let's get back to our notes. We have the same 20 students, right? I don't think we mentioned students. I think we just say people, but I'm gonna just refer to as students, right? We have 3 girls for every 2 boys, right? So that means in one group we have, in one batch, right, we have 5 students, right? How did I get 5? 3 plus 2 gives us a batch of 5, right? So that means we know that for every 3 girls are in 5 students. So this is exactly like that first question, right? 3 girls to 5 students, right? Just written a little bit differently, right? But you come to the same conclusion, right? 3 to 5, so we know this becomes 12 to 20, right? Now I also asked what else do I ask? I asked how many girls are there, how many boys are there, right? Now there's 2 ways. This is the girls part, and the boys part is right here. For every 2 boys, there's a group of 5 people, right? So 2 to 5, this has to turn into 20 to something, right? Why 20? Because there's 20 students in total, right? And this 5 represents the people, and this 20 also represents the people or the students, right? This 2 represents boys, so this number right here is going to represent the number of boys altogether. Look for a multiplicative factor. We already know it's going to be 4. Look for 2, so times 4 on that side as well. 2 times 4 gives us 8. So we know that there's 8 boys and there's 12 girls. So exactly the same as the one above, but just a different way of doing it. So second question, same thing. Oh, wait, never mind. This one, I completely thinked it. So there was 2 girls, 3 boys, right? So going back, see, that's why it's good we do this online. So there's 2 girls per 3 boys. So this would be 3 boys, 3 boys. This would be 12. This would be 8. This would be 2. times 4 times 4, right? So if you caught that, great, right? You caught that early on. So not the same answer. This time we have 8 girls, 12 boys. That's why I was like, when I created this, why did I create the same exact question, right? I didn't, right? This one you had 12 girls, 8 boys. This one we had 8 girls, 12 boys. But the idea is exactly the same, right? The idea is exactly the same. When you have part by part, where is it? Where is it? When you have this is part to part, the other one was part to whole. When you have part to part, you write them out like that. You find what the total of one group is, and then you break it up into 2 part to wholes, right? So this is a part to whole, whole, part, whole, right? And here I'm interchanging between student and people, but they're exactly the same, right? That's the entire population, student or people, right? So next question. There are 7 females for every 8 males in the course. If there are 135 students in the course, how many females are there? How many males are there? Okay, so what's the ratio here? The ratio is 7 to 8, right? 7 female to 8 males. Is it part to part or part to whole? Take a second to think. It's part to part because female is a part, male is a part. If it said 7 females for every 8 students, then it will be part to whole. But it says 7 females for every 8 male students, right? So this is a part to part because both of them are distinctive parts, right? So let's write. We have 135 students in total. We have 7 females for 8 males, right? So this is your part to part. So I'm going to write P2P, right? So part to part. First step is create your group, right? Which adds up your ratio. So 7 plus 5 gives us 15 people, right? Actually, just to stay consistent, I'm just going to say 15 students in one group, right? You break this up into 2 part to wholes, right? So these are going to be your 2 part to wholes, right? First one, we look at females. We have 7 females for every 8 students, right? That's what that's going to be. And we have not 8, excuse me, for every 15 students. And we have 8 males per 15 students, right? In this group of 18, in this group of 15 students, right? Think of it like this: 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, right? Let's say these are your right. So those are your males, and the white circles are your females. In one group, that's your ratio, one group of 15, right? Now, if you have a lot of these groups, right, because you have 135 students in total, right, you're gonna have a lot of these groups that add up to 135 students, right? Now, how are you going to do that? You're going to keep on drawing circles and coloring in and counting, right? That's going to take forever. So that's why we use ratios to do this much faster, right? So we have actually had one student that did something similar to this. It took her forever. She got it done for one of the quizzes, but it took her forever. So try to stick to this way, right? It'll be a lot faster, right? So convert this into the fraction, right? Because a ratio could be written in many ways, right? It could be written as this, right, with the colon in the middle, right? Or it could be written as a fraction, or it could be written as a decimal or a percentage, right? Which I could show you guys, for example, for this one, right? I did it right here, right? 60%. So you could say 60% of students are this one girls, right? So that says something. That's a ratio right there, right? 60% of students are girls. That means 40% are boys, right? So that in itself is a part to whole ratio, right? So back to this, right? 7 to 15. This has to somehow convert to something, right? What is it going to convert to? Now we have this 135. This piece of information. Where do we put it? On the numerator, the top, or the denominator, on the bottom? What does this tell us? Students, right? 15 represents the student, 7 represents female, right? So make sure you put it in the bottom, right? 15 something times 15 gives you 135. That same multiplicative factor is going to be multiplied over here, right? So let's take out our calculator. 135 divided by 15 gives us, let's use our calculator. I'm not going to do this off the top of my head, but it gives us 9. 9. So that's our multiplicative factor, 9, right? So times 9 on both sides. 7 times 9, that I don't need my calculator, it's going to be 63, right? So this is going to mean there's 63 females, right, in that classroom, right? So same thing on this side, 8 over 15. This is going to turn to just like this side, 135. And we know it's going to be the same multiplicative factor, right? It's not going to be anything different in this case. Because we know 135 divided by 15 gives us 9. We just did it, right? We just did it right here. 8 times 9, that gives us 72. So we know there's 72 males, 63 females, right? And if you want to check, 63 plus 72 gives us 135 total, right? That's how you check. So we know we're doing it correctly. Next one. Oh, great. We're up to recipe questions. I love these. Right. A recipe for punch calls for 4 parts seltzer for 1 part juice. Right. Again, parts seltzer, parts juice. These is part to part. This is a part to part question. Right. If John wants to make 5 gallons of punch, right, so he wants to make a lot of punch, how many 8-ounce cans of juice does he need? Right. So there's a couple things in this. Right. So this guy John wants to make 5 gallons of punch, and he wants to know how many cans, right? How many 8-ounce cans of juice does he need, right? And he's telling us that for each, each gallon is worth 128 ounces. So there's a bunch of things happening here. Let's write everything down. All right, scroll, 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 scroll. So we know that there's 4 parts seltzer to 1 part juice, right? If I'm not wrong. 4 parts seltzer to 1 part juice. So that's our ratio, right? He wants 5 gallons of this drink, right? He wants 5 gallons of this drink, but he also told us that 1 gallon is equal to 128 ounces, and he wants to know how many 8-ounce cans will he make? Can or will? What do you say? How many cans does he need? Oh, of juice. That's what he wants. How many 8-ounce cans of juice does he make? He wants to make 5 gallons of punch. Cans of juice does he need? Right? So, first of all, think of it this way, right? So, there's 5 gallons, right? You could draw this out. This is a weird looking gallon, right? There's 5 of them. Let's draw, actually, the first one looks good. I'm just going to copy that. Copy. Bear with me, guys. Right, and then I'm going to copy these two, copy, paste it, and then I'm going to copy this one again. You see how long this is taking, right? There's a reason why I'm doing this, because this is the long way, right? He wants to make 5 gallons of juice, and he told us that 5 gallons, 1 gallon equals 128 ounces. He wants to know how many cans of 8-ounce juice does he need, right? Now, out of these 5 gallons, right, and this one actually works out really well, right? He tells us that for the ratio for juice, this kind of mixture, right, is 4 seltzers equals 1, 4 seltzers per 1 juice, right? So this is a part by part. So first thing you want to do is find out the total, which is 4 plus 1. That's how much this, that's the total, right? That's the total of the mixture, right? So we know it's 4 to 5, 4 seltzers to 1 total, and the other ratio was 1 juice per 5, right? Now, here we know it's going to be 5 gallons, right? So it's going to make our life a little bit easier. So we want to convert this to 5 total, but this could indicate 5 gallon as well, right? How do we get to 5 to 5? Just multiply it by 1. So this case, it's really easy. Multiply by 1. 4 gallons of seltzer. Same thing on this one. 5 gallons. How do we get from 5 to 5? We only do multiply by 1. Multiply by 1. So we get 1 gallon of juice, right? So that means, let's say seltzer was red, juice was blue. That means out of these 5 gallons, 4 of them are going to be seltzer, and 1 of them is going to be juice, right? So we only have 1 gallon of juice. But the question didn't ask us how many gallons of juice. The question asked us how many ounces, how many cans of 8 ounces, right? So if 1 gallon of juice is going to equal to 128 ounces, right? How many cans is in 128? Just divide that by 8 because we know each can is 8 ounces, right? 128 divided by 8 gives us 16 cans of juice. Now, pause the video to copy this down for a second, right? But I'm going to change around this question. This was fairly simple, right? This was fairly simple because we wanted 5 gallons and the total was also 5, right? So it worked out for us. But I'm going to change this up a little bit to to make it a little bit more challenging, right? So copy this down. All right, now let's get started. Now, what if we were making, instead of 5 gallons, we were making 10 gallons, right? So I'm going to erase all this right here. I'm going to leave the part to part ratios because that's not going to change, right? And this is not going to change either. The total is 5. The total is going to remain 5. But what if we were making 15 gallons? What if we were making 15 gallons? And I'm not going to draw 15 gallons, right? So that means this is going to be 15 on the bottom instead of 5, right? 5 times what gives us 15? 3. 5 times what gives us 15? 3. So we do the same thing to the top. Same thing to the top. Times 3. Multiplicative factor is 3. 4 times 3 is 12. 1 times 3 is 3. So that means we're going to have 15, for every 15 gallons, we're going to have 12 gallons of seltzer and 3 gallons of juice, right? And if the question was asking us how many cans of juice are there, we know it's going to be 3 gallons. So 3 gallons of juice equals how many ounces? We know 1 is 128. So 3 times 128 gives us 384 ounces, but we don't want how many ounces, we want how many cans. Each can is 8 ounce. That gives us 48 cans of juice. Same type of question, I just changed the number of gallons. So that's how you would calculate something like that. All right? Just like I mentioned before, there are many ways of writing ratios. You can write as odds, you can write as a fractional or decimal. You guys know how to convert between one from another. That was the first lesson of the semester, right? So remember that question, 20 people in the classroom, 3 are girls for every 5, so that's part to whole, right? You can write it as odds, 3 to 5. You can write it as a fraction, 3 out of 5, or you can write it as a decimal, 0.6 or 60%, right? Because 3 divided by 5 gives us 0.6, which is 60%. Exactly what I went over a couple of minutes ago, right? Now, that goes for the mini lesson. Let's go over to the worksheet. So you click right here, ratios, proportions, worksheet. This opens up this worksheet right here. And like always, there's going to be 3 levels. Level 1, click on this. Level 2, level 3. There's how many questions? 15 questions for the first level. 1, 2, 3, 4, 5, 6, 7, 8. 8 questions for the second level, and 1, 2, 3, 4, 5, 6, 6 for the third one, right? So there are word problems as well. And it starts off with simplifying ratios, right? That's what I want to go over a little bit in the beginning, right? So I told you about how to calculate ratios. I told you about part to part, part to whole. Now I want to talk about simplifying ratios, right? Because once you simplify these, it makes life a lot easier. So let's go over two of the first. Let's go over 1 and 6, right? So 1 is 16 for 8, and 6 is 35 by 5 to 5, right? So level 1. What is 16 by 4? 16 by 8 and 35 by 5. So question 1, 16 by 8. Question 2, 35 by 5. Just want to be 100% sure. Yep. Now, this could be written as 16 over 8, right? Now, when you do this, right, whenever you simplify a ratio, you got to find the greatest common factor, right? Greatest common factor. So G, C, F. Greatest common, I'm pretty sure you guys heard about this. Greatest common, wow, greatest factor, right, between both of those numbers, right? So copy this down, pause, copy this down because I'm going to make space. All right. So we have two numbers, 16 and we have 8. What does 16 break up into? It breaks up into 1 and 16. It breaks up into 2 and 8. It breaks up into 4 and 4. That's it. Doesn't break up into anything more. 8, what does it break up into? 1 and 8, breaks up into 2 and 4, and that's it. Doesn't break up into anything else, right? Now, I could, some people could do this in their head. Other people are going to be using a calculator, right? And do whatever works for you, right? How did I do this? First of all, every number could be broken up by itself in 1, right? That's how I got that 16 and 1, right? If it's an even number, right, then you could break it by 2 also, right? So 2 and 2 times what gives us 8. 2 times what gives us 18, 16, excuse me, 8, right? The way you could do it is working backwards, right? 16 divided by 1 gives us 16. 16 divided by 2 gives us 3. 16 divided by 3 doesn't give us a whole number, that's why I skipped it. 16 divided by 4 gives us 4. 16 divided by 5, again, doesn't give us a whole number. 16 divided by 6 doesn't give a whole number. 16 divided by 7 doesn't give us a whole number, and so on and so forth. Nothing else gives us a whole number other than these, right? So that's how you're going to do it. Same thing with 8, right? 8 divided by 1 gives us 8. 8 divided by 2 gives us 4. 8 divided by 3 doesn't give us anything, right? 8 divided by 4 gives us back here, right? 4 and 2. So those are the only factors we have, 16 and 8. Next thing, we've got to find GCF. G, a lot of people forget this G part, right? Greatest common factor. Look, they both share a 1, they both share a 2, they both share a 4, but what's the greatest? Greatest is 8, right? That's the number they share the most, right? 8. So that means this is going to be divided by 8. This is going to be divided by 8, right? That's the number, right? It's kind of like multiplicative factor, but you're actually dividing, right? 16 divided by 8 gives us 2. 8 divided by 8 gives us 1. So the ratio simplifies to 2 to 1, right? The reason I'm doing this is because later on there's questions that are bigger, the numbers are bigger, so it's better that you get into this habit of breaking it down so it's easier, right? Next question, 35 to 5. Again, let's write it down. We have 35 divided by 5. And by the way, when you do this on the calculator, just to make sure, right? When you do this on the calculator, 16 divided by 8 is equal to 2, and 2 divided by 1 is also equal to 2. Again, these numbers are going to be the same. It's always going to be the same. When you simplify a fraction, when you simplify a fraction or a ratio, right, the number or the percentage remains the same, right? So make sure you're using that to help you, right? Where's this? Where's this 4 over here? Is that there? 4 by 4. I think I moved it by accident. All right. So find the GCFs of 35 and 5, right? First thing, 1 times 35 equals 35. 2, can you divide it by 2? 35 divided by 2, you can't, it won't give you a whole number. What about 3? You can't. 4, no. 5, yes. 5 times 7, right? I believe 5 times 7 gives you 35. What about 6? 35 divided by 6, can't. 35 divided by 7, we just did, which is 5. So on and so forth. No other numbers give you that. 5 is easy, only two numbers, right? 1 and 5. So what's the GCF? Obviously 1 and 1 are the same, but that's not your biggest number. Biggest number is 5. So that means you're going to divide the top by 5, divide the bottom by 5. You get 7 over 5. So this simple, so 7 over 1, excuse me. 5 divided by 5 is 1. So when this is simplified, this becomes 7 over 1. Again, you can plug it in the calculators. 35 divided by 5 gives you 7. 7 divided by 1 also gives you 7. Right? So that's how you know you're on the right track. So that was question 1 and 6. I trust you guys will be able to do the rest of them for level 1. Right? Idea is the same. Make sure you find the GCF. Make sure you're writing down all the factors, right, when you break it down, and use the greatest one to divide. Come on, just math slow. Level 2, right, now we're getting interesting, right? I'm going to go over one question from level 2 and one question from level 3 because there's not that many for each one of them, right? When cooking rice, the instructions say 1 cup of rice to 2 cups of water. What is the ratio of rice to water, right? Super easy. 1 cup of rice, 2 cups of water. So this one actually gives you the answer, right? Level 2, 1 cup of rice to 2 cups water. So the ratio is 1 to 2. What is the ratio of rice to water? 1 to 2. 1 to 2, right? 1 cup of water, 2 cups of rice. If they ask you the same thing, right? What is when cooking? Now, here's a big, what if they ask you, what is ratio of water to rice, right? That's different. Ratio of water to rice is 2 to 1, right? Ratio of rice to water is 1 to 2. Ratio of rice to water to rice is 2 to 1. So there's a big difference, right? Make sure you don't get these two mixed up, right? So the order matters in ratios. The order of writing matters, right? If it says water to rice, you put the water, which is a 2 to 1. If it asks rice to water, you put the 1 to 2. Why? Because there's a big difference between 2 over 1, which is 2, and 1 over 2, which is 0.5, right? These are not the same thing, right? Both of these are not the same. So make sure you're reading the questions carefully. Sometimes it asks you water to rice or A to B. Sometimes it asks you B to A, right? So it matters, right? So make sure you're reading this. And if it asks you something like this, 15 girls to 10 boys, make sure you're simplifying, right? 100 to 50, simplify. 24 to 30, simplify, right? So make sure you're simplifying those and try to understand, is it part to part or part to whole. I'll have solutions for this by the end of the week. Level 3, right? A kennel has 100 dogs in total. Some are puppies, some are adult dogs, right? The ratio of puppies to adult dogs is 3 to 2, right? How many adult dogs are there? Right? Again, what type of question is this, part to part or part to whole. In this case, we're talking puppies to adult dogs, so it's part to part. Puppies is a part, adult dogs is a part, right? Total is 100. 3 to 2. So let's get started. And they're asking us how many adult dogs. Level 3. We're in level 3, right? So we know there's 3 puppies to 2 dogs, right? Is that what it was? 3 puppies to 2 dogs, right? So make sure you're reading, the order matters, right? Puppies to dogs, 3 to 2, right? 100 dogs in total, right? And we know there's 100 dogs total, right? I'm gonna write A, right? So we don't get mixed up with dogs, right? So there's 100 dogs in total. There's 3 puppies and 2 adults, right? Since this is part to part, so P to P, first thing we gotta do is convert to a part to total, part to whole, right? So how much is their total in one group, right? In one group, there is 3 plus 2, so there's 5 dogs in one group. So we break this up into 2 part 2 wholes, right? So we have 3 puppies for every 5 dogs, and we have 2 adult dogs for every 5 dogs, right? So write this up in a fraction, 3 to 5, 2 to 5, right? And we know that this is going to turn into something over 100 dogs, something over 100 dogs, right? And why does it go in the denominator? Because this 5 represents a group of dogs. This 5 represents a group of dogs. We don't know how many puppies there are in total. We don't know how many adult dogs there are in total. That's why the top is blank. Now, finding the multiplicative factor, right? 100 divided by 5 gives us 20. So our multiplicative factor is 20, right? Multiply that to top as well. 3 times 20 gives us 60 puppies, 60 pups, right? Same thing, right? Times 20, times 20. 5 times 20 gives us 40 adult dogs, right? And this should add up, right? 60 plus 40 should add up to 100, so that's how we know we're doing it correctly, right? And also, just to check, 60 divided by 100 gives us 0.6, which is also 60%. And 3 divided by 5 is also 0.6, which is 60%. So it checks out, right? We're doing it right. Same thing. 2 divided by 5 is 0.4. 40 divided by 100 is also 0.4. That's how you check, right? So the question asks us, how many adult dogs are there? There are 40 adult dogs, right? So this is how you show your work. That's how you write your final answer. You box it or circle it or whatever, right? So that concludes this week's lesson. Make sure to read the description on the timesheets if you're coming back to watch it. Study for the quiz tomorrow, and if you have any questions about this week's lesson, make sure to attend the office hours on Thursday or Friday from 10 to 11. All right, guys, keep the comments coming. Great job so far, and I wish you guys luck if you're watching this on a Monday or even Tuesday morning. I wish you guys luck on the quiz. All right, take care.